Good afternoon, everyone. Thanks for joining this particular demo. So, like today, I am going through with the Palo Alto Firewall Basics to Advanced training. In this training, what are the things I'm going to cover? I'll go through with the course content, and I also go through with the lab topologies, what type of lab topologies I am going to use throughout this particular training, duration of this training, fee structure of this particular training, and what are the topic I am going to cover in this training. Like, so I'll go through with the entire course content. Once those things will complete, I'll go through with the packet flow, and also I will go through with the data path of Palo Alto Firewall, right? So those are the topics I will discuss. So now let me just start. So, this particular batch, I am going to start from the 28th June. It's a weekends batch. So your classes will run on Saturday and Sunday. Timing of the classes is 4 p.m. to 7:30 p.m. IST. So we will be having a 3.5 hours of session. There is a gap in between, around 50 minutes of break we will take between that particular time window. Total duration for this particular training is 9 weekends. So somewhere around 2 months. There are total of around 18 classes. If we will go here and there, then 18 to 20 classes I will mention, right? So 9 to 10 weekends is the total duration for this particular entire training. If you are interested for this particular training, then this is the detail. First number belongs to me. You can contact on this number. I will guide you through with all the details. Second number belongs to Bidit sir. So you can also reach out to him. He will also help you with all your doubts, all your queries. Before starting the demo, let me just go through couple of other details. So like, let me go through with our website. So cnets.com, this is our website. Here you can check out our details. Apart from this website, we do have a learning portal as well. This is our learning portal where you can able to find all the courses, whatever we are offering from this particular portal. You can also able to purchase our recorded session, like whatever you want. Let me go through with our YouTube channel as well. So let me go through from here. CNets. This is our YouTube channel where you can able to find lots of videos on Palo Alto Firewall, on AWS, IPsec VPN, FortiGate Firewall, F5 LTM, GTM, ASM, right? You can able to check out Panorama videos is there, Palo Alto Advanced Tech Troubleshooting videos is there, right? SD-WAN videos is there. You can go through with those videos if you want to know how we used to deliver the training. So you will get lots of videos here as well. Apart from that, we do have another YouTube channel with the name of Skilled Informational Academy. So first YouTube channel is CNets and the second one is Skilled Informational Academy. In this particular YouTube channel also you will find lots of videos on F5 LTM, GTM, ASM, Wireshark, AWS, Azure, SD-WAN, all those details will be available. Okay, team, let me share those links as well with you so you can able to check out our YouTube channels later. And if you will ping us on our on the mentioned mobile numbers, then also we will able to help you with the same details. This is a learning portal. Okay, now let me tell you what are the things I'm going to cover in this particular training. So the total duration for this training is around 54 plus hours. So we will be having around 54 plus hours of training. You will get the lifetime support for interview. You will get the documents for your learning purpose. Class notes will be provided to you. You will get the access of recorded sessions. So each class I will record and I will share with lifetime access through a video portal. So you can able to refer those videos later. We will help you building the lab in your laptop. If your laptop is not sufficient, because I need a laptop with minimum 16 GB of RAM, i3, i5, i5, i7 will work. If you don't have a laptop, then lab setup will be done in your laptop. If you don't have a good laptop, then we will help you building the same lab on Google Cloud. So in Google Cloud, you can able to build the lab, which is valid for 90 days and which is free. Because when you will subscribe for Google, it will give you around 25,000 INR as a free credit for 90 days. That credit we will utilize and we will create a lab over there. It's a weekends batch, as I have mentioned earlier as well. During the classes, you can able to discuss any type of issues if you are facing with your lab environment or any issue you are facing in the production environment. We will also offer the mock interview with every student. If you have an interview, you can reach out to us. We will took your mock interview and we will tell you what are the things you have to prepare, right? So those are the things which we used to offer. One more thing, guys, fees for this particular training is 7,000 INR for Indian students, 150 USD for international students. Now let me go through with the course content. What are the things I am going to cover in this particular training? So, guys, I will start your training with by explaining the platforms and architecture. So I will go through with the all the hardware models available from the Palo Alto, all the virtual firewalls available from the Palo Alto, right? I will go through the what type of hardware devices we are having, like 5200 series, then nowadays 5400 series. Why people are using 5400 series? Because these are the new generation firewalls. Then we will discuss 3200 series, 3400 series boxes, right? There will be 800 series box. Initially they do have a 2000 series, right? Nowadays the latest series is 4000. They have a 200 series. Now they are having 440 or 4400 series boxes, right? So all these hardware platforms we will discuss. We will discuss the virtual flavors as well, like we have a Palo Alto images which we can deploy on our virtual environment, like on VMware hypervisor, right? On VMware workstation, ESXi environment, we can deploy over the AWS, over the Azure, GCP. Nowadays, basically Palo Alto also have created the Palo Alto devices which we can deploy as a Docker images using the Kubernetes clusters, right? That CN series devices. So all those platforms we will discuss, right? I will go through with the architecture where I will discuss what is SP3 architecture, right? How the Palo Alto data path looks like, where I will discuss all the internal component, like this is the data path for Palo Alto 5200 series box, right? Where we will discuss the interface stack. Then we have a Qumran chip. Then we have a FE100, which is a network processor. Then we have a Octeon chip, which is a data plane 0. Then DP1, DP2. Then we have a C100, which is a signature match processor for your layer 7 protection, right? Or layer 7 inspection. So all those details we will discuss as per the latest hardware series, right? If the same data path I will tell you in the old boxes, Then in the old series, I can say like 3000 series, 2000 series, or 5000 series, right? Those boxes they used to have a Marvel chip. Now this chip is replaced with the Qumran, right? They have a Liger and Tiger here, which is a network processor. Then they have a Octeon chip. Then they have a Jaguar or Ocelot chip here for the signature match or the pattern match processor, right? So all those things we will discuss as per the latest firewall module or the firewall models, right? Once this part will complete, I'll go through with the flow logic again in your live session, which is the packet flow. So you know, I will explain you the packet flow like if I will give you the idea, right? This particular image is a very, very old image. Palo Alto released this image in 2010. That time that was the packet flow on PanOS 6. This is valid for PanOS 6. Right now, we are at PanOS 11. Even though PanOS 12 will release soon, we are at here, right? Now there's a lots of changes happened with regards to the architecture. Internal component has been changed, right? Now this particular packet flow will also change. And the latest packet flow looks like that. See, lots of new elements they have added, right? So I will discuss according to the latest packet flow. How the Palo Alto firewall going to do the packet inspection, how it is going to do the packet processing. We will discuss at each stage, like initial stage, then silo path or session setup stage, flow lookup, fast path, app engine, right? Everything we are going to discuss in detail. Then your content inspection, and after that your forwarding stage or the egress stage, right? Everything we will discuss according to this diagram. Even though in your today's class also I will discuss the same. Once this part will complete, now we will discuss how we can take the how we can make the initial configuration in your firewall. Initial configuration includes configuring your management interface, configuring the DNS settings, configuring the proxy, configuring the NTP, right? Creating the default username and password according to your organization policies, right? All those things comes under the initial setup, and we are going to do initial setup as per the Palo Alto best practice. Okay. How we can take the access of your Palo Alto firewall first time? Via the console cable, via the management port. How we can basically make those connectivity, how we can connect the firewall, Palo Alto firewall with the management interface. What are the things we have to refer? And guys, those tasks we will do with the hardware device. So I have a one Palo Alto 440 as a hardware box. Okay. And I do have a couple of switches as well. Like this is my Cisco switch. Okay. So here, if I'll show you here, then you will get whole idea, right? How I have connected my firewalls, right? You can see everything, all the details you will get here. I have created couple of port channel as well, right? Palo Alto management interface I have connected with this fast Ethernet 1/0/2, right? All those things we are going to discuss, right? How we can configure, like how we can configure all those settings. If I will tell you with regards to the configuration, let me just tell you like I'll just give the glimpse of it. Set CLI config output format set. Let me tell you what are the things include inside the management. Whatever configuration you can see here, like your domain name, host name, IP address, net mask, default gateway, all those things we will configure in your firewall. Now you can see here we are able to see very less information, but we will do lots of other information. Why we can able to see here very less information? Because this device have the configuration, but you know, as I am managing this device through one of my Panorama, okay. So most of the configuration on this device I have received from the Panorama. You can see I've received from this particular template, all those DNS settings, NTP setting I've received from the Panorama. Okay. So we will discuss, because it's a firewall training. So everything I'll do, all those configuration, you will get the idea. Even though if you want to see, you can also see like this. So template, device config system. So those are the settings which I've received from the template, right? All those settings we will configure as a initial setup. Those are the things generally I will configure as an initial setup. Okay. So everything we will discuss how we can do all those things. Once this part will complete, I'll move towards your licensing and software updates. Here I will discuss what type of license offered by the Palo Alto Firewall. Let's suppose you want to use a URL filtering feature, then what type of license offered by the Palo Alto? What is the category 2, category 4 license? Like which URL filtering solution we can opt? We can opt for the PenDB, or we can opt for the Bright Cloud. Everything we will discuss. If you want to use the IPS functionality, then you need a vulnerability protection license or threat prevention license, right? We will discuss, like if you want to use anti-spyware, anti-virus, or the vulnerability protection profiles, then you have to purchase the threat prevention license. If you want to use the global protect, then you need to purchase a global protect portal and gateway license. So all those license I will discuss, how we can activate those license from the using the support portal. That part also I'll cover. How we can register our firewall into the support portal. Those things we will discuss, and we will do all those tasks. Once the licensing part will complete, now we will move towards the software updates. How we can basically upgrade your firewall with the latest version. What is the upgrade path? So that those upgrades we will do as per the Palo Alto recommended upgrade path. What are the checklist we have to maintain during the upgrade process? We have to start the upgrade with the secondary device, then the primary, right? How we can do the upgrade with zero downtime. All those things we will discuss in your upgrade path. At the same time, I will also discuss how you can basically manage your dynamic updates. We have to manage your dynamic updates, right? Because dynamic updates have your signatures for antivirus, signature for application, signature for threats, right? URL filtering feed, right? All those details, how we can able to manage basically those things we will discuss. And what is the best practice to configure? Like if you will see my dynamic updates, then here I have configured like every 2 minute past the hour basically. Now here every 30 minutes past 2 minutes of an hour, right? How we can configure, what is the best practice for those updates? We will manage those updates by a CLI, by a GUI, everything we will cover here in your licensing and software updates topic. When this part will complete, I'll move towards the account administration, where we will create the accounts for L1 engineers, for L2 engineers, for L3 engineers. We will define their roles. According to their role and responsibility, we will provide the access of our firewall, right? All those to account administration using the Radius server, using the LDAP, or I can say your Active Directory AD server, how we can able to achieve. So those practicals we will do at this particular time. Admin roles, how we can create admin roles for L1 engineers, for L2 engineers, for L3 engineers, right? All those things we will cover. How we can provide the read only access, right? If let's suppose there is some auditor came, then how we can provide just the access or device so he can able to perform only the audit related tasks, right? All those things I will cover here in your account administration. Once this part will complete, now I'll move towards the interface configuration, where I will explain how we can configure our data interfaces, how we can create different security zones. During the same time, we will do the practicals for the layer 2 deployment, layer 3 deployment, what is vWire deployment, what is step mode deployment. We have a practicals and we have a dedicated labs for all those deployments. And around 95% practicals we are going to perform in layer 3 mode, because in most of the time people deploy Palo Alto firewall as a layer 3. Some organization they used to deploy in vWire, but there is a proper use case, and later on that vWire mode they will basically upgrade towards the layer 3 deployment. So like in your POC type of environment, people used to deploy in the vWire mode or either into the tap mode. Layer 2 deployment I have not seen so far. I'll explain you how we can create a sub interfaces, how we can create a port channel, or I can say ether channels. In Palo Alto, the same thing is known as aggregate interfaces. How we can create a sub interfaces for aggregate interfaces, because we have a hardware boxes with us, so we can able to perform all those tasks. Even though right now, if you will check my configuration, I have the same type of setup. You can see I have created 3 aggregate interfaces, AG1, AG2, and AG3. See, I have created the sub interface as well at the port channel level. So all those practicals we will see. And you know, those configuration I will cover using both. I will configure via GUI as well as via the CLI. Both things will be covered. Once this part will complete, I'll move and I'll start doing the configuration, how we can configure Palo Alto Firewall as a DSCP server, Palo Alto Firewall as a DSCP client, and Palo Alto Firewall as a DSCP relay agent. How we can make those type of configuration. So we will do those configurations. In your Palo Alto Firewall, if you want to configure anything with regards to routing, like if you want to configure OSPF routing protocol, or you want to configure RIP protocol, or you want to configure BGP, or you want to configure the static routing. What we have to do, we have to do all those configuration inside the virtual routers. So we will do that particular virtual router configuration as well. And we will also see the use cases of multiple virtual routers. In most of the organization, you will see people just have a single virtual router, single VR, but here we will see multiple VR. What I'll do, I'll create a separate VR for my WAN communication, and I will create a separate VR for my LAN communication. LAN, so like my inside in DMZ, I will create this particular LAN VR, and for WAN, I will create one more VR, and we will do the inter VR routing. We will perform the inter VR routing as well. Like right now also in my setup, if you will see, I have the same type of setup. I have a VR WAN and VR LAN, and you can see my if anything from the LAN, if we want to go to us outside, then it will go to VR WAN. So we will do those type of inter VR routing. If something coming towards my inside of DMZ from the outside, then it will come and it will go into my VR LAN. So those type of routings we will see how this routing works, right? All those particular practicals we will do at this particular point of time. During the same class, actually, I forget to mention. So better I can explain from here. During the same class, I will discuss your path monitoring, because you know I will configure this particular lab topology where I have a two ISPs, my Airtel ISP and my Jio ISP. So Airtel is primary and Jio is backup one or the secondary. Then we will do the path monitoring. If my Airtel ISP went down, then traffic can fall back automatically towards the Jio. If my Airtel came online, then traffic start going again from the Airtel side. So how we can achieve this task? So we will do it with the help of path monitoring. At the same lecture, I will discuss your policy based forwarding. PVF, like let's suppose those are the subnets. If those subnets wants to communicate with those subnets, then what I want they should follow the backup path. So those type of routing or the forwarding, if you want to configure, then we can only able to configure with the help of policy based forwarding. So those practicals we will do, right? If traffic from this test PC and this test PC. And if the application is SHS, Telnet, then he can follow the backup path. So those type of decision we can routing decision we can able to make with the help of policy based forwarding. So those practicals I will cover here, because here we have a two ISP, right? Let's suppose this ISP is having the 400 Mbps link and another one is 200 Mbps link, right? Then what we can do? We can configure those particular setup like this. So my 60% traffic follow my primary ISP and 40% traffic will follow the secondary ISP, or 70% traffic will go from the primary and 30% will follow the secondary ISP. How we can able to configure that? So we will configure the equal cost multipathing ECMP as well. So all those practicals I will cover here in this particular section. So it's just a connected session with your layer 3, layer 2, VMware and deployment. All those things I used to cover in those lectures only. Once this part will complete, now I'll move towards the core part of your Palo Alto Firewall, which is your security policies and net rules. And guys, people used to purchase the firewall just for security policies, net and VPN. These are the three functionality. When they need to configure, then they require a firewall. So guys, this is the core of our environment. Okay, those are the core feature basically. So in security and net policies, I will configure the security policy configuration, policy administration, how we can create a different rules with regards to security policies, right? We will do the policy optimization, multiple tasks we will do. Like in this particular tab, we will discuss everything. Like we will configure the application based rules, then we will configure the some general rule for blocking the traffic. We will configure the rule on the basis of country, right? Like China, Pakistan, Turkey, we can block those traffic. We will configure our internal rule, how we can able to check the hit count. All those details we are going to discuss in depth basically. Okay, we will see all those options, how we can clone, how we can override, revert, what is, how we can move here and there, how we can highlight the unused rules, how we can basically use the filter option. Like if we want to go to into this monitor tab and we want to filter, how we can basically achieve this filtering and all, right? All those things we are going to cover from here only. Okay, from this session only we will cover everything with regards to your security policies. Once this part will complete, I'll move towards your network address translation, where I will discuss your source net, destination net. I will discuss the Uternet, and the most important net is DNet, right? And destination net, we will perform three use cases. We will discuss the concept of pre-net and pre-net IP and services post-net zone, right? That concept we will see. We will configure the destination net. We will configure the port address translation, which is PAT or dynamic IPN port in the Palo Alto. Then there is a net on the basis of session distribution. All those particular things we will discuss in your net session. Okay. Once this net class will complete, I'll move towards the app ID. Application identification. I will go through with the app ID workflow. We will discuss everything, how app ID works, app ID overview, application filters and groups, how we can create application filters and application groups. We will see how Palo Alto Firewall going to do the app identification for TCP based packets, how Palo Alto Firewall going to perform the app identification for UDP based packets. Like sometime in this particular tab, let me just show you something here. If I'll go in my firewall into this monitor tab, sometime here you can able to see why we are getting the application is not applicable. Sometime we will get here unknown. Why these things coming basically? What is the reason? All those things we will discuss when we will start looking for your application app ID based concept. During the same session, I will also explain you how we can create the application groups like this. Application filters like this level 5 application, 4 application, audio streaming, file sharing, proxy app, remote access app, right? All those applications. I will also explain you how we can create the custom application like I have created for CNET portal, where I will explain you how we can create a signatures on the basis of SSL parameter, HTTP parameter, all those particular things we will perform. And everything we will do with labs. Everything we will perform with the labs, okay? With practicals. Once your app ID will complete, I'll move towards your content ID. Content ID is a core feature of your Palo Alto Firewall, which includes your antivirus protection, anti-spyware protection, your vulnerability protection, URL filtering, extra dynamic list, file blocking, security profiles, wildfire, right? All those particular practicals we will do. Here, basically, I will basically try to download one of the virus from the internet. And also, I do have a couple of malicious files on my Kali Linux for for virus, for spyware, for vulnerabilities, right? So I will try to download, try to access those type of malicious code in my packet through Palo Alto Firewall, and we will see how Firewall is going to block. Let me just show you if I have something. Like today also, like I have performed couple of practicals, like I have downloaded couple of viruses, couple of vulnerabilities, file couple of spywares, right? And how my firewall is basically providing the protection from all those. So those particular practicals we will basically do it in this particular session. Let me just check the 100 logs. See, those are the logs from today's class only, right? You can see all those are the executive files which I have created using my Kali Linux, and I have kept it on my one of my machine, and I used to download from there, and we used to see how my firewall is providing the protection from those type of viruses, those type of malicious payloads. So those practicals basically we will do live basically with some examples you will get to know. In URL filtering, basically it's a generally I used to take a 3 hours of session dedicatedly on URL filtering, where I will discuss multiple things like how URL filtering works, what is what is the PanDB URL filtering solution, what is the Bright Cloud URL filtering solution, what are the license we have to basically purchase. Then in the same class, I will basically explain you how we can block the traffic on the basis of URL categories. Like we can block all the social networking websites. We can block all the adult websites using the URL filtering. So all those type of practicals we will do. I will also explain you how we can configure the external dynamic list. Let's suppose you are getting some malicious URL feeds from some of the third party organization. Then we can basically configure the EDLs, external dynamic list. I can also explain you how you can create a custom URL category where we can create a allow list and block list, where we can allow the traffic and we can block the traffic on the basis of URL and also on the basis of URI. How we can create those custom URLs using the regular expressions. So all those practicals we will do in your URL filtering. Then we will do the file blocking, where we will try to block the downloading and uploading of malicious files. We can control what my users can download and what my users can able to upload, what type of files. So I can able to control everything. I will explain you how we can basically protect our environment from the 0-day protection or 0-day attack. Means how I can basically protect my organization from the unknown malwares. The malware which is newly created, and we are not having any signature for that particular malware, then how we can able to create? So we can able to protect with the help of wildfire only. I'll go through with the wildfire operations, how wildfire works, right? All those things we will cover in your wildfire session. Then I will basically how we can combine all those things in your security profiles, and we can basically apply in your security rules. And we will create those profiles like that. Let me just give you some idea. I'll I'll create a profiles like if I'll go for spyware, let's suppose, then I'll create default and stick. Those are the default one, which you will get by default. Then I will create one for outbound, one for inbound traffic. So in for inbound traffic, for outbound traffic, one for internal traffic, and one for just alert only. Those type of profiles I will create. I will give you the CLI template as well. You can also able to create. You can see like alert only, outbound, inbound, internal, right? Similar for your URL filtering, then for your file blocking policies, then we will combine everything in your security profile groups. Then those groups we will call in our security rules. You can see here I have called all those profiles. Okay. So everything we will see practically. And after that, the most important topic. See, guys, generally your virus, malware, or any type of malware like Trojan, any type malicious code. Generally, those codes are available in your layer 7 data. Yes or no? Those type of malicious code or payloads is a part of your layer 7 data. Those we can able to block with the help of content ID. But let's suppose if somebody is launching the flooding. Let's say he has just launched the TCP SYN flood attack, UDP flood attack, ICMP flooding he is doing. Or let's suppose he is basically try to hijack your session. He is doing the host sweeping or IP spoofing attack. How we can prevent from such type of attacks, right? Because those are part of layer 7, right? But those flooding is a part of your network. Flooding happens on the basis of layer 3 and layer 4 information. I can launch the SYN flood attack. You mean I can basically launch the DDoS attack majorly, right? Then those things comes under the zone protection and DOS protection. Here I will basically launch the live flooding attack on my Palo Alto firewall. And I'll configure the zone protection, which is very wider, and DOS protection, which we can configure specific. How we can protect from those type of flooding attack like SYN flood, UDP flood, other ICMP flood, ICMP flood, or the other IP flood. Or let's suppose I have modified my layer 3 header, layer 4 header, right? How I can basically protect from those type of network layer attack or the TCP layer attack or UDP layer attack. Those attack we can protect from the zone protection and DOS protection. So we will do those live attacks and we will protect. Now, guys, tell me one thing. Nowadays, most of the website is secure by the SSL. In SSL, what used to happen? In SSL, it will encrypt your traffic. Means whatever communication happening between client and server, it is encrypted by the TLS protocol, transport layer security. Whatever data it's flowing here, it is encrypted by the algorithm like AES 256. It is basically hashed by your SHA-256 for the integrity purpose, right? Now, if any type of malicious data is flowing inside that TLS, then how my firewall able to read that data? how it can able to inspect that data. And for that, we have to configure the SSL decryption. So we will go through with the SSL decryption. I'll go through with the certificate management where I will tell you what is root CA, what is intermediate CA, what is end user certificate, what is certificate signing request CSR, how your root certificate validate your end user certificate, right? All those things we will discuss. So certificate part I will cover here. I will discuss the SSL handshake as well. In-depth information I will cover with regards to your SSL handshake, how SSL works. Then we will discuss how outbound SSL decryption happens. Because Palo Alto will not perform any type of proxy. Okay. Palo Alto basically maintain the session keys for outbound SSL decryption, similar for the inbound SSL decryption. How it is going to maintain that those session keys, that part I am going to discuss. So once you know the SSL handshake, then only you will able to understand how outbound SSL decryption works in Palo Alto, how inbound SSL decryption works in Palo Alto. Nowadays, guys, most of the attack used to happen inside your SHS protocol. People used to create a SHS tunnel, and in through this tunnel, they can able to send any type of packets like a proxy. So I will show you. I will just allow only SHS traffic on my firewall, and through this SSH tunnel, I can send any type of traffic. When we will configure the SSH decryption, then my firewall will block those type of traffic, right? So those practicals we will do. When this part will complete, I'll move towards the most important topic, which is user ID. We will do the Active Directory integration. We will configure what are the configuration required to configure users to IP mapping. How we can use the Palo Alto user ID agent, which is built in, and how we can use the external user ID agent. In the same particular practical, I will explain you how we can create a users to group mapping. Then how we can use this particular users to group mapping in our security rule. How we can configure the user-based policies. Like for HR users, I will allow the access of job portals like Naukri.com. And for the sales users, I will block that access of this job portal sites. But for sales users, I will allow the social networking website. But for the HR peoples, I will block the social networking website. How we can able to achieve all those tasks, we will discuss in your user ID class. How we can basically configure the user-based policies, what are the things we have to manage, everything we will cover in depth. When this part will complete, I'll move towards your IPsec VPN, IPsec site-to-site VPN, where I'll go through with your phase 1 and phase 2 exchange process, like how your aggressive mode works, how main mode works, how quick mode works, what is IKE v2, everything we will cover. What is IKE version 1, what is ISACM protocol, right? Everything we will discuss. Even though I will also basically encrypt your ESP packets using the Wireshark. I will take out those particular keys from the Palo Alto firewall, which it is going to use for encryption and decryption purpose. And I have basically created around 13 use cases of IPsec VPN, which will cover almost everything with regards to your VPN in your Palo Alto firewall, like your IPsec site-to-site VPN between two Palo Alto firewall using pre-shared key. Then another one using the certificates. And instead of pre-shared key, now I will use the certificate. IPsec site-to-site VPN between two Palo Alto devices having overlapping subnet. This is the most important use case. Like in most of the time when you will configure VPN between your environment and the customer environment, they have a overlapping subnet. So that part we will cover. Then IPsec side to side VPN when one device have the static IP and other device have the dynamic IP. How we can achieve this task? Then like one firewall behind the net gateway, how we can able to configure, right? Then how we can, if we have a dual ISP, then how we can configure two IPsec tunnel. One is primary and the another one is the backup, secondary. Using the failover using tunnel monitoring, failover using static route path monitoring, failover using the virtual router and PBF, policy based forwarding. Then your IPsec side to side VPN between Palo Alto and ASA. Then we will see dynamic IPsec side to side VPN between Cisco ASA and Palo Alto, where Palo Alto side have the dynamic IP address. Then route based VPN using OSPF, hub and spoke VPN using OSPF, right? So multiple use cases we will do with regards to your IPsec VPN. Once your IPsec class will complete, I'll move towards your global protect, where we will discuss how, what is global protect gateway, what is global protect portal, what are the component of global protect. We will discuss the connection flow of global protect, because if you know the connection flow, then only you can able to do the troubleshooting. Global protect connection method we will discuss, what is user logon, on demand, pre-logon, then on demand, pre-logon, then user logon. And even though guys in your IPsec VPN and also in your Global Protect, I will discuss what are the daemons involved in backend. Like for Global Protect, there's a daemon called REST MGR. There is a AppWeb3. There is a Nginx. What is the use of all those daemons? All these things we will cover. Like in your IPsec VPN, we have a IKE manager, most important daemon of your IPsec VPN, IKE MGR. Then we have a key MGR, key manager. Then we have a tunnel D. We have a crypto D. What is the use of all those particular daemons? So we will discuss everything in detail. Once this part will complete, guys, and after it I'll move and I will start doing the configuration for active passive high availability, configuration of active passive HA, active HA, how to configure active HA lab, then floating IP HA lab, R float HA lab, mixed mode HA lab. And you know, during your HE class, I will also give you the advanced level overview of your high availability architecture. How firewall 1 communicate with the firewall 2 at the daemon level, like how system daemon from firewall 1 will communicate with the firewall 2 system daemon. How HA agent of firewall 1 will do the communication with the HA agent of firewall 2. What are the traffic logs or what are the log files we have to check? Everything we will basically do and we will basically check. Then I'll do the troubleshooting webinar as well, where we will discuss how we can use the packet filter, packet capture, flow basic, and TCP dump. How we can run the TCP dump to basically capture the management related traffic, right? So those are the troubleshooting webinars I'm going to cover. So this is what, guys, I will cover in your Palo Alto firewall training with regards to the course content. Now guys, let's try to understand today's topic, like life of a packet in the Palo Alto firewall or Palo Alto firewall packet flow. Just give me 1 second. Or before starting this topic, let me just tell you what are the lab topologies I'm going to use. So guys, this is the first lab topology which I will use. Okay, then and this will cover your static routing, path monitoring, PVF, ECMP. Your global protect practicals I will do in this lab topology. Your IPsec VPN related practicals I will do in this lab topology, where I have firewall 1, 2, and 3. and I have Cisco SA. I have a dual or triple ISP setup. So we will cover all your VPN related tasks here in this. This is a demo topology, guys, and most of the practicals with regards to your like net security policies, all those practicals I will do by using this particular topology. Let me just for BGP or for active for high availability, I will use this topology. And I will also share all those topologies. Okay, it's not like that. You will get those topologies as well from my side. For vWire deployment, I will use this particular topology. So those are the like main topology which I am going to use throughout your trainings. I have also created this lab topology, right? This also I will share if you want to use this lab topology. Like these are the ones where you can able to. And after that, like once you will get the idea, you can create any type of topology and you can able to perform any type of practical. Like for redistribution related practicals between OSPF and BGP, I will use this particular lab topology. Okay. So I have a multiple lab topologies and I'm going to provide you all of them. Now let's try to understand the life of a packet in your Palo Alto firewall. So guys, before going into the life of a packet, first let's try to understand the Palo Alto firewall block diagram or the data path. Guys, whatever questions you are having, I will take your questions in the Q&A session. Okay. Right now, let me just focus on the demo. So, every firewall, it has a interfaces stack here where all your interfaces stack or the interface module. And this interface module has a direct connectivity with one of the chip called Marvel chip. Marvel chip generally used for the copper ports. If you have a fiber or SFP plus ports, then we will have a Petra chip. This chip will have a direct connectivity with those links. Those links is known as joy links. These are the high speed fiber links and it has a direct connectivity with Liger or Tiger chip. In high-end boxes, you will see Tiger. In low-end box, you will see Liger. This particular processor is known as a network processor or session offloader. It is a FPGA, field programmable gateway array. Then this network processor will have a direct connectivity with the Octeon chip. Octeon chip is also known as data plane CPU. Means this is the chip who is going to do the packet processing. This is the chip who will do the packet processing according to life of a packet. Then this particular Octeon chip will have a connectivity with Jaguar chip. This Jaguar chip is for layer 7 task, means your content ID related task and your app ID related task. Those tasks done by this particular chip only. This is known as signature match processor or the pattern match processor. This is also a FPGA. So this was the block diagram, guys, of your old Palo Alto firewall, I can say. Latest Palo Alto firewall have a block diagram like this. This is for Palo Alto 5200 series box. So like in this block diagram, your interface module, it has a connectivity with one of the chip called Qumran chip. This Qumran chip has a connectivity with FE100. So your Liger and Tiger is replaced with the FE100, which is a network processor. Again, it's a FPGA or ASIC, and this particular processor act as a session offloader. Now your network processor will have a direct connectivity with Octeon chip because PA5200 series box is a high-end box, and it has a 3 data plane CPU, DP0, DP1 and DP2. And your packet processing done by the data plane only. Whatever session is offloaded by the data, this DP CPU, those packet is handled by the network processor. Otherwise, all the packet will be handled by your Octeon chip only. Now, Octeon chip, if whatever security policy is matching for the traffic, if that security policy configured with app ID or layer 7, if it has a layer 7 profiles or app identification, then this traffic will go into the C100, which is a signature match processor for app ID and for content ID related tasks. This is just a data path. In your live sessions, we will discuss in more detail. Now, let me start with the life of a packet now. So guys, in this particular diagram, if you will see, this is the diagram which will have all the details with regards to life of a packet. So guys, you know, Palo Alto life of a packet divided into 6 stages. The first stage is your ingress stage. Second stage is your flow lookup. Then third stage is your firewall session setup or silo path. And after that, we have a fifth stage, which is fast path. Then app ID. After app ID, we have a content ID and forwarding. So your Palo Alto firewall packet flow divided into majorly 7 stages. Ingress stage, flow lookup, silo path, fast path, app ID, content ID, and at last it is at your forwarding stage. Now let's try to understand what are the tasks it will perform in your content ID. So, or like what are the tasks it will perform in the ingress stage. So guys, let me just clarify one thing. See, today I will not explain you very in depth. Okay, because we have a limited time in the demo. We generally have a limited time and you, because you know this is a 3 hours of topic. When I used to cover your live of packet, it will take around 3 hours to complete. So here I'll just give a little bit idea. So when we will receive a packet, generally we will receive a packet, let's suppose on Ethernet 1x1 interface. Now, let's suppose this interface is a part of my inside zone. So what used to happen when I receive a packet on my ingress interface, now my Palo Alto firewall will start doing the packet processing. What it will do, it will extract the layer 2 information, layer 3 information, and layer 4 information. At layer 2, what are the main information we have? We have a source MAC, we have a destination MAC. Sometimes we also have a VLAN tag. If we are receiving the packet on sub interfaces, right? Then we do have a VLAN tag as well, right? Those are the details. At layer 3, we have a source IP, destination IP, and the layer 3 protocol number. At layer 4, we have a source port and destination port majorly. So now we are extracting the layer 2, layer 3, and layer 4, which means your parsing, your packet parsing started from layer 2, then layer 3, then layer 4. Okay. Now what it will do? Once it will basically do the parsing, it will basically, because I know I have received this traffic on Ethernet 1x1 interface, which is a part of inside zone. So I will do the ingress interface or zone lookup. I hope you know what is ingress. Ingress means when any interface receive a packet. When we will receive a packet inside that interface, that is known as ingress interface. So your ingress processing will start. Sometimes what used to happen, we are receiving the fragmented packet. We are receiving the fragmented packet. If we are receiving those fragmented packet, then what we will do? We will do the IP fragment reassembly. Because once we have a full packet at layer 3, because your fragmentation used to happen layer 3 onwards. Okay, once I have a full layer 3 packet, then only I can able to do start the layer 3 parsing. So I used to perform the fragment reassembly as well. Sometimes what used to happen, whatever packet I am receiving, it has layer 2 header, it has layer 3 header, and it is having layer 4 header. Now tell me one thing, those headers, they used to follow the TCP IP rules? Yes or no? They used to follow TCP IP protocol suite. Whatever standards defined into the TCP IP RFC, those header needs to follow those rules. If they are violating those standards which is defined at the TCP IP protocol level, those packets we will consider as a errors packet. And what we will do, we will discard those type of packets. What is the minimum size of layer 3 header, guys? What is the minimum size of layer 3 header? 20 bytes. Let's suppose we have received a layer 3 header of 18 bytes. Do you think it's a legitimate packet? So what we will do? Those type of packets we will drop here. We will drop those type of packets right away. Okay. Then, so guys, because it's a old diagram. Now you can see now directly they are going for firewall inspection. Then they are going for IPsec or SSL VPN. But as per the latest packet flow, see after this particular stage of parsing or extracting, if we have an ingress error, yes, then we will discard that packet. If there is no ingress error, now they will check the DOS block table. Because guys, sometime if somebody has launched the DDoS attack in our environment, if he has launched the DOS attack in our environment, then generally those type of IPs will be stored inside the DOS block table. Those IP will be stored inside the DOS block table. And if the IP address from where we are receiving the packet, like source or both, or the source zone, right? If we are receiving the traffic from that IP address, who is a part of your DOS block table? If yes, then also we will discard that packet right away. And when we are discarding or dropping the packet due to ingress error or due to your DOS block table, there is no log. There is no traffic log will be not generated. So guys, if you are not able to see the traffic in your traffic logs, then it's not like that. My firewall is not dropping those particular packets. Now this packet go for the firewall inspection. If it is applicable, yes. Now we will check, is my packet belongs to IPsec, SHS, SSL or GRE tunnel. If yes, if let's say packet belongs to the IPsec, then what I will do, I will check the hash, I will do the decryption, and I will do the decapsulation. And once I will get the inner header, then I will put again this packet into the packet parsing stage or the packet ingress process. And for IPsec related packets, your parsing will start from the layer 3 onwards. For SSL VPN, we will check the hash and we will do the decryption, and we will put the data for parsing here. In case of GRE tunnel, we will check the hash, we will decapsulate it, and we will put the packet again here. And the last thing, if we are receiving the packet for SHS, then we will check the hash, we will do the decryption, and we will put the packet here again. So if your packet belongs to IPsec or SSL VPN, then your packet go to into that particular stage. This is your ingress stage. Now at this stage, multiple things are there. So guys, I will share all those documents. So like those are the packet processing stages like ingress stage, session lookup or flow lookup, shallow path, which is also known as session setup stage, fast path, which is your layer 2 to layer 4 processing, app ID, content ID, and forwarding stage or the egress stage. Those are the 7 stages of your packet flow. Here I have not basically covered everything, how the parsing happens, how it will start the parsing, because now I just wanted to tell you what type of errors you will face. Sometime what used to happen, let's suppose we are at layer 3. We have received a IPv4 packet. Now, if we have a mismatch with regards to ether type and IP version, then those packets also we will drop right away. If IP header is truncated, some fields has been removed from the IP header, then if that type of packet is there, then we will drop that packet. If we are receiving a packet with the protocol number 0, then also I will drop those packet. If I am receiving the packet with TTL value 0, that packet also I will discard. If source IP address equals to destination IP, if in the packet source and destination address is same, then I will consider this is a land attack and I'll drop that type of packet as well. If there's a packet for ping of death, then I will drop the packet. If Martian IP address, then also I will drop the packet. So those are the problems. If you will face see in your layer 3 header, then we will drop those packets. Same for IPv6. At your TCP, if we are receiving the TCP header is truncated or data offset field is less than 5, check some error, port is 0, invalid combination of flags. If you have those things, then those are the packet which we generally drop. So those are the errors, guys, it will check. Okay. Same for the UDP. Then IP fragment reassembly it used to perform. DOS block table, these are the commands, guys. You can run those commands. You will able to see if IP address is a part of your DOS block table or not. You can able to reset your DOS block table. Then this is for tunnel decapsulation. Once this part will complete now, your second stage will start, which is flow lookup. This one. This is your flow lookup. Now we will receive a packet and we know it's a first packet. It's a TCP SYN packet, let's suppose. TCP SYN always a first packet. So when I receive a first packet here, now what firewall will do? Firewall now check the flow table. Now firewall try to check the flow table. It will check firewall. It will start doing the lookup into this flow table on the basis of 6 tuples. What it will do? It will do the lookup on the basis of 6 tuples. What are those 6 tuples? Source IP address, destination IP address, source port, destination port, layer 3 protocol number, and ingress zone. Those are the 6 tuples which we have extracted in your ingress stage. Those 6 tuples it will use. It will run the MD5 hash on this one, and whatever value, hashed value it will get. According to that value, it will do the lookup into the flow table. Flow table maintained inside the MongoDB database in your Palo Alto Firewall. It will do the lookup because we know it's a first packet. It's a first packet, so there is no session. And if there is no session, now your packet go into the slow path, or it will go into the slow path. Let's suppose if there is a packet match happens. A packet match happens, then it will check what is the state of the session into the session table. It will check for that stage. What is the stage of the packet inside the session table? If your stage is free, then that particular packet will be discarded right away. If the stage is opening, active or discard, then your packet TTL value will be restarted. In case of discard, your packet will be discarded. In case of opening or active, now your packet go into the fast path. If your packet into the closing or closed state, then also your packet go inside the session setup state. Free means packet will be discarded. Opening or active means your packet will go into the fast path. Discard means your packet will be dropped. If the session stays is closing or closed, then also your packet go into the slow path for the session setup stage. Those are the things available inside your session setup stage. And firewall session consists of two unidirectional flows, client to server and server to flow. So let me just show you if I have some traffic. I might have on this device. I'll just show you the session detail. How session looks like. Show session all. You can see I have a session, but they are in the discard state. So like this is the state. State is discard. Discard means when I have a session in the discard state means those packet will be dropped. See, we have a client to server flow and server to client flow. Those are the two flows will be there in a session. It has source IP, destination IP, layer 3 protocol number, source port, destination port. Okay, this particular traffic has been blocked as I know this. I think this is for the AnyDex traffic. That is the reason it has blocked. Okay. So generally what it basically uses those 6 tuples to create a flow key. Flow key just a MD5 hash value. Use source and destination IP, source and destination port, TCP and UDP. For non-TCP and UDP packet, guys, see, source port and destination port fields we have in your TCP protocol and UDP protocol. Do you think in your ICMP based packet also we used to receive? In ICMP header, we are not having any type of source and destination port field. Then which parameter it will use to create a 6 tuple? So from the ICMP header, it will use the value of identifier and sequence number. It will use as a source and destination port. In case of IPsec traffic, it will use SPI in and SPI out as a source and destination port. For GRE, it will use the GRE call ID as a source and destination, source port and destination port. Then we have a layer 3 protocol number and the security zone. Okay. Once it will do the lookup on the basis of those flow keys, and let me explain you how it will create those flow keys. So what it used to create a flow like we have seen, client to server and server to client, which is a 6 tuple. One session, it has two flows, client to server and server to client. So we have a one flow key 1, and we have a flow key too. Those are the two flow keys. If session match happens, then packet go into the fast path. If no, then packet go into the slow path. Now let's try to understand some part of slow path. So guys, today I will just cover your slow path and I will stop. I'll go here. In slow path, the very first thing it will check, which is known as zone protection. So here it will check two things, zone protection and the TCP state check. It will perform two type of check, zone protection and TCP state check. What do you mean by the TCP state check? Tell me one thing, guys. If it's a first packet, generally your first packet will come into the silo path. Now tell me with regards to the first packet, is your first packet is always a TCP SYN or not? In case of TCP, your first packet always the TCP SYN packet? No. Let's say instead of TCP SYN, let's say we are receiving one packet where it's not a TCP SYN. Let's say we have a push flag set by one and RST flag set by one. Do you think it is possible for the first packet? Do you think first packet we can receive as a TCP ACK? No. So like it will check that particular thing, TCP state check. Is first packet is a TCP SYN or not? If it's a TCP SYN, then it will allow and packet move further. If no, then it will drop the packet. If we are receiving some other packet like TCP ACK or SYN with ACK or like push packet with reset, some type of other packet, then those type of packet it will drop right away. That is the thing it will check as a TCP state check. Apart from TCP state check, we also have here your zone protection. Let's suppose somebody is doing the flooding. Somebody is doing the UDP flooding. He is using a UDP packet and he is doing the flooding. Now, because at the zone level, we used to configure this zone protection profile. If in a zone, let's say we are receiving 10,000 packet per second. If we are receiving UDP packets 10,000 per second, below 10,000 per second, it's a good sign. If let's say if somebody is launching the flooding, might be there is a high chance we are receiving the packet like 20,000 packet per second. Means this is a sign of DOS attack in our environment. So those type of packets, what it will do, it will start dropping here. It will do the random early drop. So there is a one mechanism, red mechanism, it will follow random early drop and it will basically start dropping those packets. Sometime for TCP SYN, sometime to protect the TCP SYN flood attack, we will use the TCP SYN cookies. If that is the case, and if there is any issue with the cookies and all, then also my firewall will drop the packet. And when it will drop those type packet, it will basically put that IP entry inside the DOS block table. And that and the further packets from that IP address will be blocked in the ingress stage itself. Okay. So it will do the lookup for zone protection and your TCP state check. Once it is done, now it will move further. It will check user to IP mapping. User to IP cache. Whatever packet we have received, now it will check user to IP cache. If your security zone If in our zone basically user to IP mapping is configured, then only it will check this particular user to IP cache. It will check this user to IP cache and it will just maintain that entry. Somehow I'm not sure, there's some changes happens in this whiteboard. Okay, because this information, I'm not sure why it is coming like this. Generally it used to have all the data, everything used to visible. Okay, so what I'll do, just for the reference purpose, let me refer this. What it will do, it will basically do the checks for user to IP or user to group cache if ingress zone has the user ID enabled. Okay, just to maintain the user to IP mapping, it will basically check those details. And after that, that particular packet move further and it will now go for the application cache check, because every firewall used to maintain the app ID cache on the basis of destination IP, destination port and protocol number. It will now go and it will check for the app ID cache. Here it will do the lookup for app ID cache. And why it is doing the lookup for app ID cache? Just to identify the application here itself. If we will get the application details here itself, then we don't need to go inside the app engine. Okay. And also you can see my firewall used to maintain that app ID cache. And after that will do the lookup into the forwarding table, or this is known as routing lookup, route table lookup. So in your forwarding lookup, what it will do, it will basically do that forwarding lookup just to get the egress interface and the zone details and also the virtual system for the first client to server packet. It is doing this forwarding lookup just to get the egress interface, just to get the information of egress interface. We are at this point. So when it will perform the lookup into the forwarding lookup, what it will do? It will first check your PVF policy, policy based forwarding rule. If your policy based forwarding is not matching, then it will do the lookup into routing table. If your match happens at the PVF label, then your egress interface and zone details he will get from the PVF rule itself. For layer 3 PVF first, if PVF is not matching, then it will do the lookup into the not routing table. In actual, it will do the lookup into the FIP table. For layer 2, it will do the lookup into FDB database. FDB lookup. And after that, once it get the egress interface detail and the zone details, now it will move further and it will do the lookup for net policies. Here it will do just here it will perform the evaluation. Here it will just perform the net evaluation. Here it will just perform the net evaluation. Okay. If traffic belongs to the destination net, now in case of destination net, it will do the lookup. It will do the forwarding lookup again, because due to destination net, your destination IP will change. Now for the new destination IP, we have to do the lookup again into your routing table or into your FIP table. If everything is good, now here we are not applying the net. We are just doing the lookup. Like rule number 1 is matching. Rule number net rule 2 is matching. We are just doing the lookup. We are not applying the net here. Then it will go and it will do the lookup for authentication policies. Now here it will basically enforce your authentication policies. If we have configured the user based policies or we have configured the captive portal, then it will basically do that authentication policies related task here. It will trigger the captive portal if matched, and after it will do the lookup for DOS protection policies on the base of prenet IP, postnet zone. Once after this DOS protection, now it will basically move further and it will do the lookup into your security policies. Now your security policy lookup come here. Here it will do the lookup into your security policies. If your traffic is matching a rule where action is denied, then it will discard the packet. If action is allowed, then it will move further and it will create a session now. Now here it will create a session and it will install that session into the session table. It will create that session, it will install that session into the session table. And after that, it will basically check for the tunnel inspection TCI policies. Then your protocol TCI policies, it will check for like these are the encoding protocols basically generally. Okay. We can encode the packet inside GRE, GTPU, IPsec, non-encryption, VXLAN and all, right? If everything is good, then your packet basically move towards the fast path here. Everything is good, then your packet move here into the fast path. See, security policy lookup, it will perform, create a session for TCI policies and everything is good. Then your packet go here. You can see this pointer. It will go again into the flow table. It already installed that flow. It will reset the TTL value and your packet will go into the fast path. Layer 2 to layer 4 processing. It will, if there is any error, then it will discard the packet. Now, why it is doing, again, it is doing the forwarding lookup in your fast path. It is doing this lookup again into the fast because guys, only the first packet will go into the session setup stage. Remaining packet will follow the fast path. So when we will receive a reply from server to client, that time we have to perform the lookup again if there is any no route change or no zone change. If there is a SSL proxy, then it will basically add the flag for SSL proxy and your SSL decryption will come in a picture. If application, we know the application, then we will go for the layer 7. If we don't know the application, then we will go for the app ID. Now here app identification happens. So I will not go in depth now. Okay. Because there's a hell lot of stuff. Then after application identification, packet going to your content identification. And after that, your packet finally go inside the egress stage or your forwarding stage. Packet forwarding and processing will start. Packet ingress process will start. In case of IPsec packet, if your egress interface or tunnel interface, then IPsec, in case of IPsec encryption, hashing or encapsulation will happen. In case of TLS also the same thing will happen. If your egress interface not the tunnel interface, then your packet will be transmitted. So this is how basically your Palo Alto firewall going to do the packet processing. Okay, I have not explained like very in depth. This is the old one. Okay, so in your live sessions when we will discuss, I will cover everything in depth, how all these things work, because in app ID multiple stuffs are there, multiple things we have into the content ID, multiple things I have to explain at the session setup stage level, at the first path also. And we also needs to discuss this particular part like life of a session, how session will be basic, what is the life of a session. Okay, so this session life cycle we have to discuss. Then packet flow stages we have to discuss on the basis of your network processor or on the basis of signature match processor, right? What are the algorithm available which runs on top of those processors and they will do the task, right? Each stage we will discuss in detail. in your live session. So those are the things generally from the for the live classes only. Okay, guys, this is what which I wanted to discuss with regards to this particular demo. Now let me again tell you one thing. This particular batch, we are starting from 28th of June. Timing is 4 p.m. to 7:30 p.m. It's a weekends batch. Fees is 7,000 for Indian students and 150 USD for international students. Duration is 9 weekends. And if you are interested, you can take the screenshot of those numbers. You can call us on those numbers. We will guide you with the process.